So the first thing I want to talk about, and this is Square, is retrofit. You good?
Yep.
And retrofit is essentially a client for connecting via REST web endpoints to your Android application. And kind of what they do is make it super simple to do. We're talking 4 or 5 lines of code, and it handles all the downloading, all the parsing. So it's really kind of magic when you're used to writing 10, 20,000 lines of code just to do this stuff robustly. And I was going to show a little bit of what it looks like. So here's the kind of their documentation. So something like getting just a simple GET request where the URL can vary is literally, this is pretty much the gist of the interface you have to write. So it's really super simple. So that's sort of the backbone of your stack, right? That's your interface layer. And this does come built in natively to use the core Android HTTP libraries, which are kind of terrible, to put it bluntly. But what it does allow you to do is, with a second tool, also written by Square, which is called OKHTP, allows you to swap out to use this as your backbone instead. And what OKHTP does is a lot of nice things. It will do gzip for you automatically. It'll do SPDY if your backend supports it automatically. It'll do connection pooling automatically. It does retries automatically. It does HTTP cache automatically. And you can use the expiration fields on the HTTPs and all that sort of stuff to make your cache break. So it really just does a lot of really good things. It handles a lot of network flakiness, like back-off retry and all that sort of stuff. So it's a pretty robust set. That before, everyone's trying to write this themselves, and really what you end up with usually is something that just does 1 retry, and then you abort, or maybe 2 or 3, So nothing nearly as robust as this. So that's sort of the second layer to your stack here.
Yeah, and it works seamlessly with retrofit. So if you include the library, then it just works without having to do anything to it. You just drop it in there. Now you're using HTTP, and everything else is configured.
It actually just looks in your class path, and if it finds it, it swaps out and uses it. So it's pretty simple, which is written by the same people, so that's sort of why. So it's really nice. They've more or less just exported their whole web stack, and then open source contributed a lot more to it. So that's sort of like phase 2 of the stack here, and we're going to go into detail of how this all works, but this is kind of the overview. And then the third phase is, so I haven't talked about any parsing yet, right? So all we have now is we have a downloader, and we have sort of an interface on top of it, which is retrofit. So as far as actually parsing, we're using...
So let me interrupt for one
Go ahead.
second. So here's done JSON parsing or any type of stream parsing themselves. So you know how you have to maintain state, you have to look at the object, decide what to do. Okay, it's one of those tokens. Then I go here, then I go there. You write this whole the state machine.
Your whole parser.
So you can parse through all the code and get everything done. So that you can just all this code just to get a plain old Java object. So the third part here is JSON, which again, it's expected by retrofit, but if you use JSON, magic just kind of happens under the covers, and you set the type, you build the code like we're going to represent the JSON object, and then when it comes in from the HTTP call, you just get back this fully inflated Java object, and you don't have to worry about any of the token, none of the parsing stuff. You just get objects to deal with. And objects are simpler than writing parsing code.
Yeah, so you don't have to write any of that.
No.
It's DOM, yeah. You can use Jackson if you want stream-based. It's a little more work. And also, one of the drawbacks to this is JSON with this stack will only work with JSON-based data, right? It won't do XML. But you can plug in an XML parser to this stack as well.
Yeah, Jackson has an XML library that I could not for the life of me get working, but it's easy to swap in the converter if you can get the converter working in the first place. I couldn't get the converter working, and I hit a point and stopped fighting with it.
It's a little harder, but you can do it. So that's JSON. So that's sort of like the whole stack. So I kind of want to talk about what I've made so far and kind of where it's going. So to come here, I already kind of made a project to start with here that we're going to add this web downloading to and see how this whole stack works and how to make use of it. So basically what I have so far is just a kind of a simple application that it's hitting Twitch TV's client or their web API because it's all open and you don't need a key or anything, so it makes it easy to demo. And basically it's going to download it, it's going to render it into a list view and just show you the preview of the channel and some text, the title, and that sort of thing. So basically parsing all the data and then a simple UI to show how it works, right?
Well, that's the goal, is to be able to have that tab map on a device that downloads all that information and puts it all together and shows you this list view with all the information from the web. Right
Yeah.
now, this is just an app with a shell. There's an adapter.
Yeah.
There's an API client. And if you click through the classes, right now they're all
Yep.
empty.
Yeah, basically the adapter has data, but that's about it.
How the adapters.
So yeah, there's not a whole lot here, and I realize people probably, show of hands, who's ever done Android at all? Couple. Okay, so I'll go somewhere in the middle here. So it's basically a brand new Hello World application, and then I just added the UI code, and there's a to-do in there where it's time to download the data, and I have a method that'll take that data and just render it. So I'm not going to cover how that rendering stuff works, but I'll cover how to get the data parsed and in there and with all this good stuff. So basically now, so where do you start, right? Now I have this Twitch API I want to hit. How do I do it, and how do I do it in less than a couple days, right? So to start, basically, so I already talked about the stack. So we basically just have to go to their website of each of the three of them, and they have the jar file. So Retrofit right off their GitHub page has the jar that you can download, and I already have them saved off, so I'm not going to. Square OKHTTP, so that again is your downloader. It does all your HTTP stuff, so that is also a jar, so it makes it nice and easy. You don't have to integrate it into your project or anything. It's difficult. And JSON, which interestingly is just a, and in fact, I think all three of these are just Java. I don't think they're Android specific, so you might actually get used for these other places as well. So JSON, I know I've used it on other projects for sure. And again, that's just a jar, so you can just download it. So basically your first step now is, now that we have the three of these downloaded, ooh, I guess I lost them. Did I lose them? I guess I lost my cheat sheet. I'll just re-download them. It's fine.
The challenges of live coding.
It really is, right?
So they're all in Maven. You could use Maven if you like Maven. You can use Gradle to have that take care of you for the downloading, or you can just download them yourself and import them to your project, depending on what your build process is and what you're doing with it. Initially, for this demo, we're just doing it with a simple download and put it in your libs directory. And
Yep.
You can use them from there.
So basically, and this is Android Studio. It works very similar in Eclipse if using that. You're just going to drag and drop these into your libs folder. So libs, okay, and then I got the other two down here. Libs, and then the one gotcha. If you're in Android Studio, you got to make sure you sync Gradle, which is this little guy, or it won't be able to see any of the files. Which will probably baffle you the first time you do it. So now we have the libraries installed. So then the next step is, okay, so how do we connect? Like, what are we hitting here?
And now we need, so if you have an API in mind, you go to that API publisher's website or wherever they have their information, and you go and grab a sample API call. So that what you need is actually the output, or what makes it easiest is to grab a sample response from the API. So you take one of those pieces of output, and then we'll show you how to turn that into how to generate objects that match that perfectly for the library.
Yep.
But the plan is that if you don't have an API, you find an API that you want to work with, or if you have one in mind that publishes, that makes available a JSON endpoint, you go poke it for a second and get a typical response back. And then from there, you can go and continue the process of actually building the app so that it can do that for it, so that it can interact with that.
So for this demo, I was just looking for something that's a simple API that doesn't have any auth, because that doesn't really prove the demo here, although you can accommodate that. So I would look for Twitch TV. They have a lot of public APIs. And the one in particular that I chose was Streamlist, which is sort of like the root level display of all the popular shows that are on right now. So their documentation's nice, it's online. And when you're browsing through here, it talks about the parameters, and it gives some examples, which is actually the easier way to just browse at this. So the one that was interesting to me is this list.json. So by default, it's XML. If you put this .json, then it'll JSON it for you. And so what I did is basically, I took this, I ran it through list.json, right? I didn't put any parameters. I'm just getting the basic response here. And what it gives you is this nice JSON response, right? And if you look at it, so we have the same object just kind of keeps repeating, right? And each one is kind of has the channel info. It has the overall info up here, and then inside you have this channel info, and it has the screen cap URLs and the name of the game, League of Legends, and that sort of stuff. So looking at that, I can say, okay, this is an array of this same content, right? So the way I want to do this, so again, we're trying to do this parsing without writing any code, as little as possible. So what I do is I find a sample output, this guy right here. I copy paste one of these, right, all the way down to the bracket. So I have like one representative item here, right? And then what I like to use is this JSON schema to pojo.org site. And what you can do is, I think I lost my savings on this, but I'll just cheat on this one. But what you can do basically is you just paste it in here, and what it'll generate. Now there's some settings you want to pick. Is you want to pick. You come in here and you do your package name. So you'd want to go to your app and see where you plan on putting it.
What this does is it reads through the JSON that you paste in there, and it builds classes that match the structure of the JSON. So that as long as you're using, and it's got options for which libraries you're using as well. So as long as you're using the library that you've chosen, everything should just work. And you can either download a jar that contains the classes that it generates, or it'll preview the classes, and you can copy them out of there and paste them into your project. And as long as you put the classes in the right structure, as you've told it between the name and the package structure here, you won't have to do anything to make it work like you want it to. It'll just all work because everything's in the right. The package is all right. It's using the right classes. I mean, there are a couple of settings here that you can play around with. Builder methods, primitive types, long integers, double numbers. There's a couple of things that you can set up.
So,
Go
yeah.
ahead.
Will that also do the type annotations for the nested requirements?
The nested objects, you're saying?
Yeah.
It will actually.
Nice.
So let me show you this one. So yeah, I don't want to type in all the package name because it's a pain to line up. But basically, just figure out where you're going to stick this, right? Type in the correct package name. Give the root class a name. I'm just going to call it Twitch TV data. It doesn't really matter. You want to pick JSON because this isn't a schema. It's just JSON, right? So that's one of the tricks. Try to pick a representative entry because some might be missing fields. Just try to pick the biggest one if you're going to use this technique. Annotation, you can actually annotate it with Jackson or JSON and that sort of thing. I pick none because in this case, when this generates, these objects are going to line up exactly because I'm generating it from them, right? So there's really no reason to annotate them. And I like to use primitive types so that I don't have to do null checks, but you can also not use that and then just make sure you null check everything because you could have blank integers or strings and that sort of thing. So then all you do in here, you can generate the jar, but I usually just do the preview because I think it's quicker. And what it generates here, so the first thing we see here is channel. So that was actually the interior class. If you go back to our list here, because channel is inside, right? So it generated channel, and then it has each of the things here. It does get a little wonky on some stuff. Like it adds this additional properties flag that I usually just delete because I don't need it. And maybe some of these fields here, you might see like object subcategory. It probably messed that up. In this case, I didn't care. But sometimes this isn't 100%, but it'll probably get you 90% there or better.
It saves you from a lot of typing.
You don't have to type all this crap out, which takes quite a while. So it gives getters and setters for everything. And then if you keep scrolling down, it'll have the second one. It'll have the higher level one down here too. So here's the second one, Twitch TV data, and that's the name we gave it. So you see you have to give the name for the root level, and the interior ones I can just generate because the names, they have to line up. That's the way JSON works. And if basically what you want to do is use this to get you really close, and then you can pull up the JSON documentation and tweak any issues. But for simple stuff, it usually just kind of works.
And that's what when I said magic happens, that's it. JSON uses the structure of the object that you give it as the top level that you want to jam the JSON into, and it uses the names to match things up so that as long as you haven't lied to it about the behavior, it'll just jam things in there, and you've got strings and primitives.
Because it just auto parses. It just takes a Pojo and takes JSON, looks for names that line up, and it just makes it, is how it works basically.
So
What's
that's
your
also-
question?
So if you think about it, that does introduce a slight bit of danger in you have to be very careful with your data classes because if you do introduce inner fields, so JSON doesn't care about whether they're private or public either. It uses reflection to populate the fields. So you can use private fields in your classes, and if you're not careful and your API developers don't communicate, they just add something to the API, and you're using one of those private fields for your own instance, but they happen to guess that field name, and the object that they send you back contains that field, the field's going to be populated for you, and it might not be what you want. So be careful with that. Just a warning, a heads up, keep your eye out for that.
Yeah, and if you don't want the names to have to line up, you can use the annotations and do it that way. But it's a little more work. Did you have a question?
If you throw two instances, like if you actually use the array structure from the,
I don't think it'll figure it out.
won't figure it out.
No, so what I usually do is when there's arrays, I'll just take one of them and paste it in, and then when I'm writing the parser, I'll just put list in front, and it'll figure it out that way. Like I said, it's not 100%, but it gets you really close.
This is just a website that's a free available website
Yep.
that does the guessing and the code generation for you, and then if you need to, like if you're using an array,
It mostly just saves you from typing
you create
that.
as an array of those objects, or lists are the same way. If it's a list of objects, I think you can use array or list. I'm not certain about the exact details of GSON, but I'm pretty sure it's comfortable with either.
So basically, I have I save these off just for speed here, but I'm going to paste in those two generated classes right now. And like I said, usually I paste them in and I delete that objects thing they do at the bottom just to grab all additional tags because I don't really think it's terribly useful. So at this point, we generated this channel thing, and we generated this stream data, which is the higher level class. And again, when you generate it, just point it to your correct namespace, and you won't have to even mess with this. It'll just drop right in. So at that point, we have this. Okay, so we have these POJOs. We don't have anything downloaded or working yet, right? So kind of the next step is, so now we should actually write a class to go download some stuff and parse it. So to do that, I'm going to, yep, I will cheat a little bit. And I think it is this one. Nope, one up. So this is actually the entire API code. It fits on one blown up giant screen. It's actually really simple, which is what I love about using this stack. So basically, I guess some of the overhead here is we made this a static instance because there's really no reason not to. This is using, again, retrofit as kind of the base. So what you're looking at here is pretty much all retrofit code. You don't really see OKHTTP, that's under the hood. You don't really even see JSON, that's under the hood. Because, again, retrofit will just use JSON if it's included and give you a really cryptic error if it's not. So that's good to know, too. So basically, all there really is to it, so there's two steps. Your first step is, and this is just some Java-ism if you're not too familiar with Java, but basically I want to make an instance of this thing if it doesn't exist yet. So your first step is basically create a REST adapter that just points to your endpoint. And that's it. So basically, a new REST adapter, and you just give it the URL of where your base address is. Pretty simple. You'll get that from your API.
If you wanted to use an analogy, this would be the phone number of the person you're going to call. Just give someone a phone with a phone number pre-dialed into it and handed them the phone.
But no interfaces at all. It's just, here's your base endpoint, right? So that's step one with retrofit. And again, all this stuff is in their documentation. It's fairly decent. It's not a whole lot to it, but then again, there's not a whole lot to APIs in general as far as the interfaces go. You only have a half a dozen things, really. What are you yelling at? Oh, all right. Does that say? I thought it said your computer is rebooted because of problems. That's great. So that's step one. Step two is now we have to define the interface, right? And this is where you go to your API documents or the guy sitting next to you that wrote the thing and ask him, how the heck do I actually communicate with this thing? So in our case, we're going to flip back to our interface document that we got from Twitch. And so what they have is, so we know the base URL. So that's kind of step one. So we know it's API/stream/list.json, right? So that's really, you're annoying me, go away. So that's basically this right here. So, and it's the annotations are dead simple. So get request, you put the word get. Post, you put the word post. Super simple. It has head, it has all the basic stuff. So get request /stream/list.json.
So what it does is it takes the endpoint and it builds the API with the data based on the endpoint API or the API endpoint, so that you can call all the different paths on your RESTful API with different methods
And it's
pass
dead
the
simple.
arguments you
Yeah.
want,
Like it doesn't get any simpler than that because you've probably written hundreds of lines of code to do this sort of stuff before. And then this name's arbitrary. I just called it get streams. And then basically what you can do, now there aren't any here, but say you had an optional, like say it was streams/username/list.json, right? It'll support that sort of stuff dynamically as well if you need to do dynamic URLs. In this case, we just have query parameters. So, and to figure those out, I just go back to the documentation here. Yep. And in this case, I have a long list of stuff, right? So I don't want to load it all at once. I want to page it, and when I get to the bottom, load another chunk and another chunk and another chunk. So I expect to see some sort of page size parameter and some sort of offset parameter. So when you look at their documentation, you see just that. You see, there's also some other ones I don't care about. But there's limit, so number of results returned, default 50, max 100. So I want to set that to something. And you see offset, so return your offset, default is 0. So again, when we request it with nothing, we're just getting page 0 and 50 results because that's your defaults. So in this case, we are just going to say, and this is as simple as it is, query parameter, and that's the name of the field on the endpoint, the string limit, right? And this is us. I call it limit too because that makes sense. So it's an int limit, and then a second query parameter called offset, and an offset. And that's as simple as defining the interface is. So the second part is now the response type. So how the heck, like how does this parsing actually happen now, right? I don't see any code. I see one line of code here. So this is all the parsing you wrote is right here. Is literally all you have to write. So in this case, callback is the way you denote to retrofit that you're going to have an asynchronous callback when the request is done.
Yeah, you can operate retrofit in 2 modes, and you can change the mode. It's not per adapter or endpoint. It's what you can operate retrofit to either do it synchronously or asynchronously. And I believe you can actually do it on the same endpoint, or you can call the same path on an endpoint in asynchronous mode or synchronous mode, depending on which method you call. Because if you look, the return type of this method is void. So what happens?
Yeah.
The return type is void, and it's got a callback as the last parameter. So the callback, what happens when you make that call, retrofit recognizes that, and it immediately yields control back to the thread that made the call. And then once the network traffic happens and it's actually got a real POJO for you to work with, it takes that POJO and it calls methods on that callback that then have to route back into your code so that things can happen. Or if you wanted to, you could wait for the call to come back, which you'd have to do off the UI thread, but that's Android. You'd have to be responsible for not locking up the system, but you can wait for the call to come back and then immediately proceed from there, but you're holding everything up if you're doing that. And
the way they did that's really simple. I mean, basically all you do, if you want a callback, you put this last parameter with the word callback in it, and you get a callback. If you don't want a callback, if you want it synchronously, then just put your return result right here. Just put your type right there, and it'll be synchronous. Now, the only catch on Android, as he's saying, is you're not allowed to run downloading on the UI thread. It'll crash the app. The OS crashes it for you. So depending how you architected it, either approach is valid. It just depends how you build it. Question?
Can you extend callback if you need to do some kind of pre-processing?
You can.
Okay.
Yeah, and we're going to cover that a little more later. But you can.
callback is an interface, so
Yeah.
Sweet.
you have to implement some kind of callback. We'll get back to that. We'll call you over there.
Call him back. So okay, so then the last part of this really is where's the parser? Where's like the 300 lines of code where you're tediously parsing and probably get it wrong 10 times and don't realize it? It's right here. So basically all you say is callback, and then it can be any type you want inside. In this case, we know it's a list, and here's where I'm manually putting the word list, right? So I'm just saying it's a list of this Justin TV stream data, which is our root level object. And that's it. That parses it. This will do everything. So all I do is I instantiate an instance of this guy. I call get streams, and it does all the parsing, does all the downloading, and comes back to you. So that's sort of our next step.
Yeah, that's the only thing that's left in order to implement this is to write that actual call to the API that gets the data and does something with it when it comes back. So that's Bill Wizards.
Yep.
It's not a lot of code even.
It's really not. So I'm just going to go to our main activity class where it's waiting. It's waiting and laying in wait to download something. So this class, just to give a little bit of overview, is when you first open it, it detects that it's empty. It creates a list view, and this is all Dapper Android talk that some people will know, some won't. Scroll up. Yeah. So, what?
Scroll to the API call.
Oh, well, in a minute. It basically is going to make a grid view, which is an Android UI construct. It's going to detect that it's empty. It's going to go download the data. It's going to get the data back, and it's going to populate it. And then as you scroll and hit the bottom and run out of data, it'll automatically go download more data and append it. So I'm not really going to cover how all that UI stuff works. I'm going to show how this downloader wires into it. And I kind of try to keep it kind of isolated here. So basically, I have this method called download data. And it's at this point where it's detected it needs to download data. And it should just do it right here. So here's basically our client. So there's the client we just wrote. And it's singled in that grabs our stuff, right? So, or I should say it's static instance that grabs our stuff. So get Twitch TV API client. So that gave us our client who has one interface to do that one call, and that's it, right? Get streams. And get streams, if we recall, wanted the limit, so the number of items on the one page, the offset into the pages, and then a callback, and that's it, right? So I did a little bit of tracking. I just made a constant in this file called items per page. I think I set it to 50. And then page number, I start at 0, and every time I finish downloading, I increment it 1. So all we're doing here is just multiplying by what page we're currently on to get our offset for our subsequent requests, because this method will run every time we try to get more data and keep track of where it was. And there's just a callback, and again, it's that same list type and the same data type. And really, that's all it is. That'll download it, and then you have a success method. It's called code folding me here. I'll just scroll over. We have a success message thread and a failure one. And what's nice about this is this comes back on the UI thread. You don't have to worry about threading. It'll do everything in the background. You don't have to worry about that. And if you have a failure, you can just handle it here. It'll actually give you the errors, and you can parse it and do something specific if you like. In our case, I didn't really handle the failure. On the success, basically, I just have a nice method called consume API data, and it just magically takes the data and makes it render. So it kind of hits some of the complexity there.
But that's all you have to do is, you're getting a full, or you should be getting back a fully inflated Java object, and then you never have to consider parsing or anything. If consume API data is called with the object, great, you've got everything you need. You don't have to do the rest of the stuff that you need to do. If it's called with null, you have to do whatever you have to do in the interface. And that's to do on this particular app.
So then to kind of show what it looks like, unless it crashed, yeah, of course it crashed on me, is,
Use the giant Android device.
yeah, you can if you want. Apparently my laptop crashed while I was sitting closed for the presentation. Yep. Let me let that boot.
Yeah, I was gonna say.
No, I don't use, well, here's, okay. I have a good reason here. There's good reasons. Because reasons.
Launch it on this.
Hold on, he lost my track of thought. So I never use the emulator for any reason other than demos, because I find it generally worthless. And I have a wealth of phones at my disposal, which is very nice. But Genymotion, yeah, it is the best thing in that world. But I still recommend just never using any simulator ever. Well, emulator ever. A simulator would be a stark improvement.
Genymotion is kind of like a simulator. That's why it's so fast.
Yeah.
So here we have the world's largest Android device.
Oh, he's got it. Nice.
Can't spin any further. Because it ports. So we launch the client. That's the root of our orders. This is downloading data from the internet as we speak. Model.
Yep, and then when you hit the bottom, it will auto start downloading your next
So that spinning is, it's it's hit close enough that it's decided to start downloading the next page.
It's kind of like the gist of any application, and it's 200 lines of code, maybe 250. I mean, you could write this in an hour or two if you know what you're doing. So it's really, really powerful. In the past, you would spend a month just getting this back engine working. And now, I mean, you could almost do this in real time. It's super, super easy. And the great thing about it, too, is so with that little bit of code, so we were, what did we write in total? Maybe 15 lines of code? 20 total? And the rest was auto-generated. And now we have all the advantages. We have download caching, we have gzip, we have all that sort of stuff. We have auto retry and back off retry. And we don't write any of it, and it's very robust.
Sure, Rich, you care how easy this is? Next time I try to tell you how long it's going to take.
Some of that has to do with API development.
So we're going to transition into a second part.
So some of the that's good to get up and go quickly and get you moving, and now you've got an API parser. Now, one of the things with JSON is at the very beginning, everything that JSON is going to be strings and integers. So if you want objects or strings and numbers. So what if you want something that's a little bit more robust as far as objects go? Like maybe some of the problems you might run into would be my API requires a 1 or a 0 for true and false instead of true and false, because that's how the API was designed and that's what we have to work with. So, or maybe you don't have access to the API developers. Maybe you're using Justin Streams or whatever, Twitch TV's endpoint, and they're like, no,
And
you
could
can
just
use it or
read
you cannot
as a
use it.
string, and then in your code do all this goofy logic. But it's a lot cleaner if you can just convert it at the interface layer and not have to deal with whatever strange representation they're using.
Right. You can either always have to write code that says, okay, 1 I know means true, and I'll just keep doing that, or you can write. The better thing to do would be to write a method on your Pojo that says, okay, get me the Boolean value of that as opposed to the int value. But why even bother with that? One of the things that one of the really neat things that Retrofit lets you do is you can, if you don't like the way that something works, you can adjust the way that it works. So what I'm talking about right now are actually converters. And give me 1 second to find the correct file here. So API client, this is the same API client that Bill just finished building, but the REST adapter has some extra stuff in there. So in the converter, well, this is the this is the API client that Bill built. And then I've added a converter and a request interceptor. What the converter does is that lets me say that whenever I get a date. That's a perfect example of things that are fun to parse. So dates are going to come back as strings. You can't get a date object from JSON. It's going to give you a string or an int, maybe, or a long. Yeah, maybe it's seconds or milliseconds since epoch. Maybe it's the string MON space blah, blah, blah. But in this case, it's actually the latter. It's the day of the week, the month, all that fun. So if you want to say, for all dates, let me get myself involved there. Let me jump in and build an actual date class so that I don't have to get that string, go get my date parser, build it into a date, and then deal with it. I just always want to treat them as dates. The change I made was I've registered, you create a builder that is going to be responsible for building your JSON. You register the type and the converter. So you can convert either coming from the API or going to the API or both. You can have one class that does both directions or one or the other. And you create that, you build all your classes that you want to interject. So here I have commented out a string reversing deserializer because why not? I mean, so you get strings from the API, spin them the other way, just for fun. So I can show that if anybody's interested, but I have that commented out because it really messes up the URLs. And it's really hard to get images with backward strings. Basically, you build the converter, you stuff that into the adapter, and then from then on, anytime a date object is expected. So how do you tie those together? So I've noticed I've got the date class and the game class here. We'll come back to game, but date is pretty simple. Date is good old Java date, so really. And the way that I let the API know that I want to deserialize that into date is I go into just in stream TV data, and I change my uptime, which happens to be a string, into a date object. And then whenever JSON sees that date object and it's trying to jam whatever it's got for the value for that uptime key into the object, it's going to call my deserializer. So let me jump into the deserializer. Oh, this is too big. It's almost readable. So you create a class that implements JSON deserializer and takes that object that you want to deserialize. Here I've created a simple date format. They're not thread safe, so I synchronize around that so that we don't get weird threadness and weird dates. That's happened before. That's always fun. This is my, so here's, I copied the text that the date would give me from the API, and then I built the date formatter to read that into a date object. What happens is when JSON goes to convert to build that POJO for you and it sees this key, it goes, gets an instance of this and gives it the JSON element and asks it for the date back. So you have full control over what you do when the API sees, okay, here's a date, you deal with it, give me a date, or here's that key that you wanted me to handle. No, it says that key that you wanted me to handle is a date, so give me the date, here's the JSON element. And all I'm doing here is grab the string, create my date object, parse it, and pass that back. So it's nothing fancy Java-wise, but I never have to, never anywhere again do I have to touch that date logic. I can just say, as long as the API is sending me dates like this, from now on, just give me back dates. When I build my object, I can say, this is a date, this is a date, this is a date. And I get date objects. I never have to do date parsing myself. It's all handled by the API. So if we take it a step further, something that might be interesting is if you have an enumerator, or an enum rather, that you need to deal with. So you know that you can only have a set number of values for something, and anything else that doesn't fit in those values you want to show up as unknown or junk or whatever. You create a Java enum. So game is another one of those objects that I said, listen, whenever you see a game object, let me handle the deserialization. I'll give you back the game. Thanks, JSON. So these are just objects that I found in that JSON snippet, and the enum itself converts from a string into an enum value. This is just simple string matching just for proof of concept, and then getDescription prints out the text as based on that enum that it got back. So again, this is really simple. JSON is that object from the parser. We get the string out of that, and we ask the game enum to parse that into a game enum for us. We get that back and we pass that back. So my game enum is in charge of handling what strings it turns into what objects, and the only thing I have to worry about is that now I've got a game object and it's going to be one of those enum values, so I can go on with my life as a developer.
And the nice thing is it's binding it to every interface behind that. So you don't have to bind it to each single one of them.
Yep, so if you have multiple endpoints and you get this game object back, you can build your objects out that represent the values returned from the endpoint, and you just reference game, and anytime you reference game, it'll call into this method to do that enum creation from the string.
So this is where you troll your coworkers with really hard to find data errors that you just slide in a nice little piece of code that creates a couple extra random characters.
Well, if you wanted to introduce, you could introduce randomness. So, like, why is this enum coming back this way sometimes and the other way other times? That's if you were looking to have things thrown at you and Nerf darts accelerated at your head at a rapid fashion. No. So the Twitch TV client that we had nothing to do with authentication. It was just anonymous. You open API, whatever. What if you have to do authentication? So one of the things that you have to do with authentication usually is you have to take some information and stuff it into the header so that the API can identify you as who you say you are and know that you're allowed to have this data or you're allowed to access this particular bit of information. How do we do that? The not correct way would be to write methods that take the request, get it out of the request builder, mangle it just the way you want, and then send it off. You don't have to do any of that, thankfully. In the API client, you can set a request interceptor, and that request interceptor can handle all that. So what will happen is you set this as the request interceptor for your API client, and then anytime an API call goes out, it has the opportunity to be intercepted. It will be intercepted. You can selectively choose to or not to intercept it here if you want. In this case, we're always intercepting it, and if we have a cookie, we're going to stuff that in the header, and we're always going to set a user agent key, just so that whoever we're calling can have those pieces of information, and you can take whatever you want and put those in there as well. So if you can imagine, if you wanted to do something where you have to authenticate and then prove that you're that authenticated user, maybe you get a token back, and you always send back that token in the header. So what you do is you go into API client. I'm not going to show this, I'm just going to talk through it. So here's our Twitch TV API interface. You would have a login method that would give you back a token, and then a do something authenticated method that does something authenticated. But if you called that without logging in first, you wouldn't have the token, it would fail, you'd get the error, the not authorized, how do I fix this? What you do is you could wrap, one way that we've done this, you wrap the interface, you provide methods that interact with the converter so that what happens is when the login method returns, that is put into the, where is it?
Callback.
Oh, I'm missing it. I'm
So you
off
can
the
basically
screen.
take a
You
callback
put
response and just wrapper it, and whenever it comes back, if that off key came back, just suck it out and save it off into your class here to get tacked on from then on.
you put that into the private request interceptor, so nobody else has access to that outside of the API client class. But then now all of your requests will have that token added to the header so that they'll appear authenticated and you won't get the unauthorized exception.
And one of the nice tricks on this that I like too is you can, if you go down to the interface, you can actually just wrapper. So what we do is we just take the callback class and we just create a base callback that has everything passed through that. And it just keeps a reference to the real callback and allows you to basically intercept all responses. And what I like to do there is things like look for unauthorized errors, and if you get it, to just throw up an event and handle it that way. So that way your entire application can catch things like unauthorized and permission or offline or that sort of stuff.
In one place rather than...
Yeah, in one place rather than 20 spewed all over that you probably missed half of them. So it's really nice to be able to consolidate that.
Does it have any support for standard authentication challenges like this rule, this API needs basic auth headers, like built in
You can add the basic auth yourself using that.
using the intercept?
Using the request interceptor, yeah. That's a very
And
tame...
I know, OKHTTP will do the normal act once and then go back with the password.
Okay.
So, and I don't know if you can override it to just send it the first time. You probably could, but I haven't tried.
Yeah, that's what I was curious. Like,
Yeah, 'cause that's
you
speed
show
bump.
both sides, you should be able to just do it. So I was wondering.
So that's sort of a little more of the advanced stuff. And so using this, we've here used this in two different applications. We use this whole stack basically. And really the problem you end up running into, so this is great, but it still has this problem if you know Android where you'll be on a screen downloading and then I rotate the screen and that just kills the whole screen if you don't know how it works. It kills everything. And now you have this downloader
Doing it
running
right.
off in the weeds whose response just falls on the floor. And you probably, after you rotate it, say, oh, I haven't downloaded it yet. Let me go download it. So you end up downloading superfluously and throwing out the results. So one of the things we have to do is figure out, well, how do we gracefully handle this? And we took two different approaches on two different applications, mostly just because of architectural considerations at that point. So the one approach that I used was I made basically a request manager class. And what that did is essentially instead of going straight to here to get your request, they all went through the request manager class. It would wrapper the callback, right? So it listens for all callbacks. And when you call him, he gives you a UUID out. And that UUID is yours to hold on to, essentially to say, I'm waiting for this request. And so what would happen is when that request finishes asynchronously, if that UUID is still bound, if you still exist essentially as a listener, it just sends it out. So it's just pub sub. So now you have, okay, well, what about rotation? What happens? So what you end up doing is when the screen rotates, you detach from your listener. This class is still living. It's a singleton. So it's still downloading in the background. And when you finish your rotation, you still have that UUID because you saved it off. You reattach to the manager and say, I'm alive. He either delivers the results immediately if it's already finished, or waits for it to finish and then delivers it. So you get kind of an easy way to handle that rotation.
And what we did was we actually used async task loaders, which do the same. They do a very similar thing. So that's just another class that lives off outside of the scope of the activity, and you can rotate all you want, but this class is around. It calls the download, it talks to the API client, and it doesn't care how many times you rotate. When it gets its data, it's there, and you ask it for its data when you finish your rotation and you've got everything rebuilt and you're ready to actually show the user something. You just go, hey, you got any data for me? And it gives you the data, and you do what you want with that data. So you can rotate all you want. I mean, you run the risk of spending network calls to actually download information, but at the same time, the only way that you would do that, I think, is if you backed out of the activity before it returned. So it's not much. The user's given up at that point. I mean, you've already made the call. You might get data back that you don't need, but there's not much you can do.
There's different trade-offs to each. The trade-off on my approach is you have to be very certain to detach your listener when you rotate, or else you're going to leak the whole activity, which is very bad on Android world and very easy to do. So if you're going to do that approach, you want to bake that attach, detach stuff into your base classes so there's no chance of messing it up. But yeah, I think that's about it.
So yeah, I think that's, like Bill said, I think that's it. If you have any questions,
Questions?
you in the front.
Use this at all with any kind of actual model storage behind it, so you're just kind of throwing stuff into the nether once you're done with it. So like actual offline caching.
We weren't doing any caching on our project.
I mean, you'll get basic HTTP caching. And really, I don't. Yeah, I mean, there's other things you could do, I suppose.
You could-
like a SQLite
Yeah.
server or something like that if you actually needed to do some advanced.
And you could conceptually do that too. You could take a service and just call the API client, take the data, jam it into the SQLite database, and then update from there. And
You could probably
maybe if you
wrap
put a
it
content
all
provider
back,
in front of
just
it.
dump everything in SQL if you wanted.
Right.
Hmm.
You know, and then put some sort of expirations on it and do a custom kind of thing. At least you have a nice single point of entry.
Right. And it decouples the API from the actual rest of the controlling code behind it. It's a pure model.
You could even conceptually make or override, well, I guess implement callback in such a way, implement a base callback that will write to SQL and one that won't, and then it's up to you whether you want to save the data or you just want to let it go after you're done with it. So
Yeah.
when you pass that callback, the callback is just an interface. You can pass an implementation of the callback that saves it, or you can pass an implementation of the callback that doesn't, depending on whether you care about it or not. So if you want to save some of your information, but not like maybe you're downloading a bunch of images in your app and you don't want to save those in your SQLite database, but you want to save all the information that those images belong to, and then re-download the images each time. You could save the image URL and not always the image. So the image download, well, you could use a different library to do the image downloading. Giant glossing over is happening. But if you wanted to, you could do that all through retrofit, theoretically. And
Square
then
wrote that too.
we glossed over
Yeah.
that.
I think this is actually really great for that because you could just put a manager class on the top, right? And on the way in, intercept all requests to see if I have in my database. Don't bother making a request and just return it synchronously, right? And then when it comes out, just intercept that and dump it into your database too. So I think it would actually work really well for that if you want to go a second tier cache.
Yeah, something a little bit more.
Yeah.
Plus.
There's a request interceptor. You could also, if you wanted to test heavy network traffic, you could create a request interceptor that just took your requests, held on to them, and sat there. 30 seconds later, okay, go ahead.
That's a good point, actually. I use that for debugging quite often.
Yep.
Especially on Android, you always want to test this rotation. It's in the middle of downloading. Does that work correctly? So I did this, and then I just have little debug menus in the app where I can say, make every API request take 20 seconds, you know. And since it's all gone through one place now, you can just add that delay. It's actually really, really helpful. And you can also, what I did too, is made it so I could just set arbitrary error codes. Just, again, through the app, just like developer settings page. So I could be on any screen and just inject it. And if you're familiar with Android, you could just send an intent from your command line and just inject an error. So your very next request is this error, which is really helpful for testing specific things on specific screens.
Right. When I've downloaded 3 pages of the TV stream, and then I want to go download the 4th, but I want that to give me an authorization error or whatever, and just send that intent. Then you scroll to initiate the 4th page download and see what happens.
I think that was the biggest benefit I saw using this too, was handling auth errors and offline errors and whatnot. It gets really, really simple, which is amazing. It never has been before.
Are there any specific gotchas for unit testing, or at mocking?
Well, it's just an interface. Like, it's an interface, so you can implement the interface yourself, and then
the API, the stuff from Foursquare or from Square in general, is it?
generally their stuff is really
They're
easy
usually pretty
to
friendly.
unit test, just because. I mean, this is just a straight up interface.
Straight Java.
And you could, this up here in the API client above the fold, you could actually, like, you see it tells the API client, the builder, to actually give me one of those, but you can implement a test one of these that does whatever you need it to,
You
or
can mock it straight from the ground
yep, because it's just a straight interface. There's no behavior. You mock it and you tell it. I mean, some of the mocking libraries even let you only partially implement something by mocking. Like, you tell it, give me one of these interfaces. I don't care about the behavior of the 90 other methods. I want to test this one method. When this method gets called, then give me this object back. But I don't want to implement the rest of the junk that I don't need to test in this specific case. And this would be, so this is a simple one method interface, but like once you have an actual backend that you're supporting, it's a lot larger. But that would be a great use case for that. Is
I think
that
it'll plug in nice with all the existing stuff. I don't see why it wouldn't.
Yeah, I've seen it mocked fairly easily with
Yeah.
electric.
Mhm.
Easily mocks.
or Mockito or
First job in mocking.
Question?
Do you recommend any Eclipse tools for implementing API?
For
Andrew.
APIs, not really. There's nothing close centric to it.
Android.
Like the only real tools I use is like I use a Chrome plugin that'll auto JSONify things pretty for you, which is nice. Which I think you saw when I was browsing through. I don't think Eclipse has really any sort of
If you
plugins for
use
that.
a Mac,
basically done at this
you
point.
can get the
We're basically done at this
it's
point.
still a thing now where you have a preference pane that it will add fidelity based upon some certain kind of network if you want to. So it'll basically mock, but understand it's at the operating system level now, so it's like futzing with your routing tables and things like that. So you can turn it off, but you can make it be like, oh yeah, I'm on a really crappy 3G network
Is
that's got like 500 milliseconds of delay, and
But that's if
So is that
you're
what you were referencing? Like intercepting requests and that sort of stuff? Or?
it's not it's intercepting requests at the operating system.
that's if you're
Yeah.
that's if you're using an emulator.
So if you're using it's emulator
Or
or Jenny
testing.
If you're trying
yeah.
to do that on Mac, I would use Charles HTTP proxy and just
It's
man
like-
in the middle of all your requests.
Yeah,
And then
Charles
you
is
can-
like-
you can inject
Charles
any sort of
only
delays.
catch port 80 and 443. So
The
you
paid
have-
one will do whatever.
so
It's
you
like
have to
$30
watch.
I think for the whole thing.
You can
can
probably
wire shard
wire
too.
the preference pane adds a lot of additional latency related stuff.
But to me, that's what I like. At least I'll use Charles proxy, and that'll even man in the middle HTTPS, which is nice. It'll just truly man in the middle with even encryption. So if you're trying to debug it at that level, at like the socket level, then that's really helpful. Anything else?
All right, thank you.
Yeah, thanks for coming.